Hello students, today we study the principle of superposition of waves. So before going to the principle, we discuss our common experience in the musical program, a musical concert. In the concert, there are some musical instruments and singers singing their songs. There is tuning among the musical instruments. There is tuning between musical instruments and singer, and because of that we hear pleasant effect of sound. That effect is due to the interference of sound waves. It is due to the interference of sound waves. This interference is because of superposition of waves. In that hall or in that region, there is overlapping of sound waves. They superpose each other and then they produce certain effect. That effect we call it as interference of sound waves. And such effects we can explain mathematically as well as qualitatively. We can explain that effect according to principle of superposition of waves. So first we read the principle of superposition of waves. If when two or more waves traveling through a medium. In our example of concert, musical concert, there may be 4 or 5 types of musical instruments there. More waves are traveling through the medium, and if they are passing through a common point, each wave produces its own displacement at that point or in that region, independent of the presence of other waves. So each wave produces its own wave, own quality of wave, and the resultant displacement at that point is equal to, here, the vector sum of displacements due to the individual waves at that point. So this part is related to vector sum, overlapping of waves or superposition of waves. This we have to understand. So for that we consider one example and then we explain the interference of two waves. So here we have taken example of sound waves. The waves may be transverse waves or longitudinal waves for the interference, but we have taken the example of interference of longitudinal waves here. But that interference can take place when two or more transverse waves are there, as well as two or more light waves, means electromagnetic waves are there. So here the basic is that the principle of superposition of waves. Then we can explain interference in sound waves as well as interference in light waves. In our Wave.6 chapter, we explain the interference of light waves. In this chapter, we have to study interference between the sound waves. So now we have to deal with the principle of superposition. So for that, we take the example of stretched string. Again here stretched string is there. Now try to understand carefully. Here stretched string is shown by AB, and two persons are there to hold this string or to keep the string horizontal, tight and stretched. Now, if the person at point A vibrates the string up and down and producing the crest here or producing a pulse here, and that pulse is traveling in this direction. At the same time, B is also producing a pulse. It is in the form of a crest. Both the pulses are produced at the same time. They are having the same displacement. In vertical displacement is also same. In amplitude of each pulse is same. They are traveling towards each other. Now, in the second time instant, they are approaching each other. Here at the start, the time is denoted by, or time is taken as 0. The next instant we take as t is equal to 1 second. Now, if we take the t is equal to 2 seconds, then they are crossing each other. They are very close to each other or crossing each other in this way. Crossing of two waves are there, two pulses are there here. Now, in the next time instant, say t is equal to 3 seconds, they overlap. Here there is overlapping of the two pulses, and the result we observe as there is maximum displacement at this point. Now, after overlapping, the time instant is 4 seconds. The two waves separate each other, or two pulses separate each other in this way. Slight separation is there. Here, the pulse which is produced at the left end is passing towards the right, and the pulse produced at right end is passing towards the left. But here this is also can be considered as a region of crossing, and after again 1 second, means for the time instant of 5 seconds, the pulse is separated from each other like this. They are going away from each other, or they are receding from each other. At the next instant of 6 seconds here, the right pulse is towards left, and the pulse which is produced towards left is now going towards the right, because this pulse has given energy to move from left to right, and this second pulse which is produced at right end is given the energy in such a way that it must have to travel from right to left, and at a certain instant they overlap. Here there is overlapping of two waves or two pulses. There is superposition of two pulses, two wave pulses, and the resultant displacement is maximum. We show here the maximum displacement in this way. It is greater than the individual displacement. This effect here is produced that there is maximum displacement. But after overlapping, both the waves or both the pulses travel in their own direction, which is given by the source. Here for the first pulse the source is A, for the second pulse the source is at B. So here in the last diagram we observe that the first pulse is going towards right or right end, and the pulse produced at the right end is now arriving or going towards the left end, because energies are provided in such a way that they have to travel from left to right, and second is given energy to go from or to travel from right to left. So they maintain their direction. Waves overlap. First point, after overlapping, they maintain their direction. So this point is very, very important. They maintain their direction and shape. So try to understand carefully here. In the last diagram, we have observed that pulses move or pulses travel in their own direction. So, but in the middle diagram or at the instant of 3 seconds, there is overlapping, there is superposition. We observe the maximum displacement at the point where they cross, where they overlap, but after overlapping, they maintain their direction as well as they regain their original shapes or they maintain their shape. This is the unique property of wave. This is the unique property of wave. So here you have to note this property, that waves can overlap, and that overlapping can be explained by the principle. But after overlapping, they maintain their given direction as well as they maintain their shape because of the property of wave. This is the unique property of a wave. Now here the displacement is maximum. Now again we explain by considering some mathematical details here. The two waves are arriving at a point or they are approaching towards each other. They are having same phase. They are having same displacement or same frequencies also we can say here. They are having same frequencies. And now in the third figure they are crossed each other, just crossed each other, and in the fourth figure they have superposed each other. There is overlapping of the two waves, and the effect is addition of displacement. Therefore we observe there is a maximum displacement. And after overlapping, they separate each other or they try to go away from each other. They are receding their maintaining their direction and shape. Here the resultant displacement is maximum, we observe here, because and it can be explained by the principle in the second statement here, that the resultant displacement at that point, means at the point of overlapping, is equal to vector sum of displacements due to the two individual waves at that point. So the displacement can be, suppose for the first wave it is y1, for the second wave the displacement is y2. So there is addition of displacement, that displacement can be written as y1 plus y2. Here, therefore, as there is addition of two displacements, we observe the maximum displacement, and this effect here, overlapping effect is called as the constructive interference. So 2 points mathematically we have to add in the description, that when two waves arrive at a point in same phase with same frequency along the same path, then there is superposition of waves and the resultant displacement is maximum, then that effect is called as constructive interference. Now we take again the same setup to understand the another type of effect on the same diagram here. That diagram I can draw here like this. Suppose at the end A, crest is produced. Here first crest is produced, or one pulse is produced which is having convex shape, and here the person is there at end B. He is disturbing the string in such a way that he is producing a pulse which is pulse number 2, but it is in the form of a trough. Concave part is produced here, and both are arriving towards each other. Both are approaching towards each other. Here we show the approach or approaching waves in this way. Some undisturbed part is there. In the next, here they cross each other. Now in the next event of 3 seconds, at a certain point, here first pulse is there, second pulse is there, one is crest, other is trough, but the effect is shown by this line. This full line is shown. This is the effect here which is produced here, and that is the minimum displacement. Minimum displacement at that point, because of one crest and other trough, minimum displacement is produced, or zero displacement is produced here. And after producing this overlapping at that point, or superposition here, superposition, after producing the effect, each wave goes again to their own direction So trough is traveling towards A, crest is traveling towards B, like this, and in the time interval or time instant, say 5 seconds, here trough is traveling like this, crest is traveling towards A and B, and they are separately traveling like this. At the next instant of 6 seconds, they are well separated from each other. Here, at the instant of 3 seconds, crest and trough overlap each other. There is superposition, there is certain effect, producing minimum displacement or zero displacement sometimes. That effect is called as destructive interference. Destructive interference. Here we have taken stretched string. On that we have studied two types of interference, constructive interference and destructive interference. In this destructive interference, there is cancellation of displacement. One displacement is suppose y1, another displacement is y2, but it is denoted by minus because it is produced along the negative y direction. So y1 plus minus y2 is the minimum displacement. Here resultant displacement is y. It is minimum or it is exactly equal to 0. But after overlapping, after superposition, each pulse travels in their each pulse travels of its own given direction and maintain its shape in this case also. So here at a point where overlap, after overlapping they maintain their direction and shape. So this interference is called as destructive interference. So both these types of interference, constructive and destructive interference, we have explained by considering the experimental setup of stretched string. Here again I write the stretched string, means considering the example of transverse waves on stretched string, but we apply this for the longitudinal waves also or sound waves also. So when compression of one wave overlaps with compression of the other sound wave, then there is constructive interference. But if compression and rarefaction of other waves overlap each other, then there is destructive interference as explained in the transverse wave. In case of transverse wave, I can write here, if crest and crest overlap, trough and trough overlap, then there is constructive interference, and if crest and trough or trough and crest overlap, there is destructive interference. So this is about the explanation of effect produced due to the overlapping of waves, and that explanation is according to the principle of superposition. Again we read the principle: when two or more waves traveling through a medium passing through a common point, we have taken one common point there, each wave produces its own displacement at that point independently of the other, and the resultant is equal to the vector sum of displacement due to two waves. To understand the principle of superposition of waves, we consider two waves producing the displacement y1 and y2. For the first wave, amplitude is a1. Its expression can be written as y1 is equal to a1 sin omega t minus kx. For the second, y2 is equal to a2 sin omega t minus kx plus phi. So from these two expressions, we note here that amplitudes of two waves we have considered is different. Frequency omega, angular frequency is same. Direction of propagation is same. Along the x direction the waves are traveling. And phase difference between them is phi. Here omega t minus kx, here omega t minus kx plus phi. So here phase difference of phi is there. But we consider here the effect at x is equal to 0. Then we write y1 is equal to a1 sin omega t, y2 is equal to a2 sin omega t plus phi. So this is our first expression to apply the principle of superposition, because we are considering here the point at which x is equal to 0. Now, according to the principle, the resultant displacement is the vector sum of two displacements. So we write here y is equal to y1 plus y2. Here a1 sin omega t plus a2 sin omega t plus phi. We expand the second term as a2 inside the bracket sin omega t cos phi plus cos omega t sin phi. Now this expression can be written as y is equal to a1 sin omega t, and here in the second term a2 sin omega t cos phi. So we take sin omega t as common and we can write here sin omega t, but inside the bracket here a1 plus, in the second term there is a2 cos phi, a2 cos phi. And the third term here is a2 cos omega t sin phi. We write it as a2 sin phi cos omega t. Simple expression there. Let us substitute here for the bracket a1 plus a2 cos phi. We substitute as a cos theta. And for the second term, here we take a2 sin phi is equal to, we denote for it as a sin theta. This is for the sake of calculation of resultant amplitude. So this expression we denote as, here equation 4, 1 is 5, 1 is 6. Now substituting this in equation 4. Y is equal to a cos theta sin omega t plus A sin theta cos omega t. It can be written as y is equal to A sin theta plus omega t, or we can write omega t plus theta, and this is the new equation number 7, where A is resultant amplitude. Actually, in our individual waves, amplitudes are different. They are A1 and A2. Now, in the new wave or the resultant wave is having amplitude which is A, which is called as resultant amplitude. But the frequency, angular frequency, same as that of the individual wave. Sin A1 sin omega t, here omega and omega is maintained here. Here phase difference between two waves is phi. Resultant phase is theta, but we are interested in only the amplitude here in this particular derivation. Now resultant amplitude can be obtained by considering equation 5 and equation 6. So let us take the square of equation 5, squaring and adding, equation 5 and equation 6, we get one equation here. So first we square equation 5, it is A1 plus A2 cos phi square is equal to A square cos square theta. This square we easily write A1 square plus twice A1 A2 cos phi plus A2 square cos square phi. It is equal to A square cos square theta. This is our equation number 8. Now, squaring this equation 6, we get A2 square sin square phi, A square sin square theta. Now, this adjustment, instead of giving numbers, we keep it as the adjustment of squaring. Now, we add both the equations, LHS as well as RHS. For RHS, it is simple A square cos square theta plus A square sin square theta. It becomes equal to A square. And towards the LHS, it is A1 square plus twice A1 A2 cos phi. And the third addition, A2 square cos square phi, A2 square sin square phi, it is A2 square simply. So we get here the equation as A square is equal to A1 square plus twice A1 A2 cos phi plus A2 square. We take it as taking square root on both sides. A can be equal to under root of A1 square plus twice A1 A2 cos phi plus A2 square. This is the equation number 8. So, in our explanation of constructive interference and destructive interference, we have used the description as two waves are crossing the point, they are producing the effect, and we observe the maximum displacement, sometimes minimum displacement. Those displacements we can give with the help of formula number 8 or equation number 8. We consider here case 1. If phi is equal to 0 degree or 0 radian, then A is equal to under root A1 square plus twice A1 A2, because cos 0 is equal to 1 and third term is A2 square. So A will get here A1 plus A2 whole square, and it can be A1 plus A2. The resultant displacement is addition of two individual displacements. So this is the maximum displacement. Maximum displacement, and the effect in diagram or the effect we observe is known as interference. That interference is constructive interference. So in the description we have stated in that experiment that when two waves arrive in phase means the phase difference is 0. If the two waves arrive at a point in phase, then the resultant displacement is maximum and the interference is called as constructive interference. Now if in the second case we take phi is equal to 180 degree or pi radian, then A is equal to resultant amplitude is equal to A1 square minus twice A1 A2, because cos phi is cos 180 is minus 1, therefore we directly write here, and inside the square root we get A1 minus A2 whole square, or the difference in displacement A1 minus A2. The displacement is here minimum displacement, and the interference is called as destructive interference. So our sentence is that when the two waves arrive out of phase. So let us again, for the recall of the destructive interference, we have shown that crest is arriving here, trough is arriving at a point. The disturbance produced here is like this. Crest and trough both are arriving at this point. They are out of phase. They produce the minimum displacement here. The resultant displacement is minimum, and the effect produced is called as destructive interference. In both the cases there is superposition of waves, but types are different. If the resultant displacement is maximum, then that effect gives us constructive interference, and if the displacement is minimum or 0, it gives the effect which is called as destructive interference. So in the superposition of waves, we have to study the interference and two types of interference, constructive and destructive, according to the principle of superposition of waves, in which the main point is that we have to consider vector sum of displacements due to the two waves or due to more waves. In our example, we have taken only two waves for the superposition. This is about the points, mathematical details of the principle of superposition of waves. So today we stop here. Thank you.